Alright, welcome. This is a 10-4 video that we have right here. So make sure that you write this theorem down that we have right here. So we're going to be talking about perimeter and area of similar figures. So remember, we've talked about similar figures before, where it is just a shape getting like bigger or smaller, and it's depending on the scale factor that we have right there. But yeah, it's just like a triangle, and it's the same triangle, and we just enlarge it, or we take that large triangle and then we shrink it. So depending on the scale factor, and then remember that our scale factor right here was A over B. Remember, we set up ratios that we have here. And so the only difference that we're going to have though is when we have the ratio of a perimeter, it's going to be A over B, and when we have the ratio of their areas, it's going to be A squared over B squared. And we can think about that though, because when we're doing perimeter, we're doing like a one-dimensional. Hence why when we find the perimeter of object, we just say inches, 24 inches, or 34 centimeters, because it's just one dimension from here to there. But when we're talking about area, we're talking about two-dimensional. We're talking about the thing inside, and we square the units, so squared inches, squared centimeters. So when we're dealing with these ratios that we hear, we're going to also square when we're talking about similar figures. Okay, so let's do some problems to make this a little more clear. Alright, so our first problem, write this down with the picture that we have right there. So it says the trapezoids at the right are similar. Again, similar means that one just got bigger or one shrunk right there. And so it says the ratio of the lengths of the corresponding sides is 6 to 9 or 2 to 3s. So it wants to know what are going to be the ratio for the perimeter and for the area. So remember, when we are, it gives me the corresponding sides are 6 to 9, so we see 6 to 9, or 2/3, and all that really did is just simplify that that ratio that we have right there. So for our perimeter, if we're trying to find out what that ratio is going to be, well, it's just going to be A over B, and it gave us that right there, which is either 6 over 9, but we simplify that, it's going to be 2/3. And when we're trying to find that ratio for the area, it's just going to be the same thing, but we are going to square A squared and B squared. So we're going to get 2 squared over 3 squared. This is going to give me 4 over 9. And we can't simplify that anymore, so that's going to be my ratio right here. So again, just kind of finding the ratios right here, but let's do a problem where we'll actually use this to solve. Alright, so for this problem, it says the area of the smaller regular pentagon is about 27.5 square centimeters, and it wants us to approximate what the area for the larger pentagon is going to be. So first, it gave us the area of this smaller pentagon. So we're going to write area is going to equal 27.5 square centimeters. And the first thing I'm going to do is I'm going to find my scale factor. Scale factor. And again, my scale factor is taking corresponding sides. So if I see this side and this side, those are my corresponding sides. Now I'm going to go from small to big. So again, it's going to be A over B, and so I'm going to get 4 over 10 that I have right here. And what I'm going to do is I'm going to have my these corresponding sides, and what I'm going to do is I'm going to set up a ratio. I'm going to set this equal to, well, if I know that the area of the, and again I put the smaller one on top, so the area of the smaller pentagon, and I'm going to set this up as a ratio of the area over the larger pentagon. And so that's what I'm going to do that I have right there. And I was given what this area for the smaller one was, and so we know that this is going to be 27.5, and we are trying to set up the area, we're trying to figure out what the area for the larger one is, approximation. But the only thing I gotta be careful of though is when I did this right here, I gotta remember that if I'm finding the perimeter, it's just gonna be A over B, but I am finding area. So area, I gotta make sure that it's gonna be A squared over B squared. So I have to square both of these when I'm talking about area. So let's write, this is gonna be 16 over 100 is gonna equal 27.5 over x. So I'm going to cross multiply. This is going to give me 16x is going to equal, I'm going to move the decimal over 2 spots. I'm going to get 2,750, and then I'm going to divide both sides by 16, and so x, and we're talking about approximation, I have 2,750 divided by 16, and this is going to give me approximately 171.875. We're talking about square centimeters. I got to make sure we're talking about area, so I got to make sure I square that, and this is going to be my final answer. So again, we just got to be really careful when we are setting up our scale factors. If it's perimeter, just a over b, but if we're talking about area, it's got to be a squared over b squared. Alright, and our last problem that we got right here, it says the triangles to the right are similar. So what is the scale factor? Well, what is the ratio of their perimeters? And we are given area. So I wrote down these 3 things. We want to find scale factor, perimeter, and it gave us the area that we have right here. So I just got to remember, if I'm trying to find the scale factor, that's going to be a over b. My perimeter is going to be the same thing, a over b, when I'm finding that scale factor for perimeter. But my area, though, area is going to be a squared over b squared. And so in this one, it gave me the area of the smaller one and the bigger one. So I'm going to put the smaller one on top and the bigger one over there. And again, anytime we have ratios, we always want to simplify the ratio if possible. And so if we look at 50 and 98, we can see that a 2 right here can go into top and bottom. So let's simplify this first. This ratio, when simplified, is going to give me 25 over 49. Okay, so again, we got a little square right there. In my area, that scale factor is going to be a squared over b squared. So if I'm thinking about this, if I have a squared over b squared, and if this is going to equal 25 over 49, well, I want to go, instead of a squared, I want to figure out what just a is, though. So again, how do we get rid of that square? We're going to square root. So if I square root a squared and b squared, it's going to give me a over b. So all I need to do to find the scale factor and the perimeter is I'm going to square root both sides, and this is going to give me 5 over 7. And so that is going to be my answer that I have right here for my scale factor and my perimeter. It's going to be 5 over 7. Okay? Thanks for watching. See you guys soon.